apologize for the technology glitch, but thank you, APA, for the invitation to present the contents of this ACI guide to design and construction responsibilities of architectural precast concrete. I am Don Meinheit. I'm retired from Wish-Janney Elson Associates in Chicago, and I am a longtime member of ACI 533, and basically am a practicing structural engineer. I'm not a precaster, but I've been working in the area of precast concrete pretty much over my 40-year career. Just briefly, here are some learning objectives for this discussion. The most important is the third bullet, where the ACI document defines the responsibilities of various parties in the construction of architectural precast concrete. Before getting to that bullet, I would like to also review and describe some history of the design responsibility requirements, emphasize that in every project, need to develop lines of communication. We'll then get into the responsibilities of various construction team members and review forms of contract. And also in this presentation, I will define a standard of care. This is a list of the ACI 533 members who were part of the group who voted and produced this particular document. The chair of the committee, ACI 533 committee is called Precast Panels. It not only includes architectural precast, but also structural precast panels. The chair is David Wan of Old Castle Precast. The secretary was Karen Polanco from Metromont. Karen is also now the existing chair. David has retired from the chair. And there are several members that maybe you recognize names in this list. One might be George Beatty from Crescent Chemicals. Harry Chambers, unfortunately, is deceased, but he was a longtime member of ACI 533 and worked for TRW Nelson Stud Welding. Brian Miller has long been associated with the precast concrete. I believe he started working for the National Precast Concrete Association, moved to the Pre-Stressed Concrete Institute, and now works for GCP, materials supplier. Larby Senior is the president of the Consulting Engineers Group, a specialty structural engineering group. Venka Shihapa is the chief engineer at Gate Pre-Stress in Florida. And maybe one of the consulting members' name you recognize is Friedman. That's Sidney Friedman, a retired person from the, who is the director of architectural precast at PCI. So these design responsibilities were initiated because there was some relative confusion about the authority that was given to the various people in a project. And this is probably prior to 1990, early 1990s. ASCE first published something in the late 80s, and that publication was really the outcome of an unfortunate collapse. And you might remember the Hyatt Regency collapse of the walkway, and there were some issues with respect to design responsibility that initiated this whole discussion on design responsibility. They first published a document called Quality in the Constructed Project in 1988. That document is now in its third edition and was published most recently revised in 2020. In 1987, ACI created a standing committee at the board level called Responsibility in Concrete Construction. And they first published some guidelines for authorities and responsibilities in concrete construction in 1995. And it was the action that ACI took that provided the ACI 533, the initiative to produce a document, and that this whole issue of responsibility breaks down into two basic principles. The first principle is responsibility and authority should go hand in hand, and every entity in a construction project should be responsible for their own work. Kind of makes sense. In the middle of this is also the third edition of the quality in the construction project produced by ASCE. This is also the first, the cover sheet of the 533.1R-20, the guide for design and construction responsibilities of architectural precast concrete, published by the American Concrete Institute. And it is, as Tim said, sent to all of your certified APA plants. It's 11 pages long, and I've added two pictures. One on the left is kind of a historic, older precast concrete project. This is the Baha'i Temple here in Chicago area. And the one on the upper right is a church in Chile, which is an APA award winner. Now the design, the ACI 533.1R, this design and construction responsibilities document was previously first published in 2002. In this revision to the 2002 document, we have improved and added some additional information. The reason the 2002 document is no longer around is that ACI requires all of its committees to reapprove, update, or revise, or in some cases withdraw documents within an 8-year period. ACI Committee 533 elected at the end of that 8-year period, which is 2010, to reapprove it. But ACI says, you're not going to reapprove it forever, so you got 5 years of grace, and then you need to decide what you're going to do. So in 2018, we had another option, and that was that ACI said you got 3 years to revise this, or it comes off of the ACI's publication list. So we met that deadline, and so in 2020, we republished this document, and it is now available. Now, I think everybody understands modern construction projects are very complex. And it is very logical to have input from all the parties of the project. And that's an absolute necessity. You can't, there's no one entity that knows everything about the construction. So inputs such as value engineering proposals, design alternatives, and the performance requirements rather than prescriptive requirements are all good inputs for a construction project to make it acceptable to the owner who's paying the bills, as well as keeping the cost within the budget. So let me play with this just a minute. Suppose we have an architect engineer saying that they require a contractor not to undertake certain tasks without the approval of the architect or engineer. And then suppose a problem develops from execution of those tasks, but the AE says they're not going to accept responsibility for those problems. Well, that's a conflict. That's a case of requiring compliance, but not without accepting the responsibility. Another scenario might be where owners have sued the architect and the engineers for approving poor quality construction, but at the same time didn't give the architect or the engineer a contract to monitor work progress. Here the owner is assigning responsibility without providing for compensation for giving the architect and engineer any kind of inspection authority. Project success seems obvious, but it's worth repeating. Clearly define the scope of the work. And it starts with the architect, but it also needs to be clearly defined and understood by everybody in the project team such that the architect's concepts are manifested. Also, some clearly defined responsibilities are necessary, and that those responsibilities are both in scope and in execution, such that we can achieve efficiency, cost. The project is cost effective. It is by all means safe to construct it, and that the structural engineer and other parties have designed the structure to be safe for the loadings, but during construction, it is also necessary that the work environment be safe, as well as producing high quality product. There are 5 basic chapters to this design and construction responsibility document. There's an introduction and scope. There's a section on definitions, which is new to the 2020 document. Then there are, the 3rd chapter is called general responsibilities, and that's what we'll talk about more in detail, but that defines the responsibilities of the various parties in the construction project. Then there's some guidelines on hardware responsibilities, and lastly there's procurement and the bid process and how we go about getting the structure built. So who should be who should be participating as part of the project team? And this is the part of the team that deals with architectural precast concrete. Certainly the owner needs to be involved. An architect is the master planner, and he needs to put on drawings what his concept is for the structure and that he and the owner have agreed to. There's a structural engineer of record who doesn't necessarily design everything with respect to the architectural precast, but he designs the structure upon which the precast concrete is attached. There's either the construction manager or the general contractor. And then the last 3 items are like the 3rd group within this team. It's the precaster, the precast specialty engineer, and the erector. So the team kind of breaks down into 3 segments. There's the owner, the architect, and the structural engineer. Then there's the construction manager / general contractor. And then the thirdly is the precaster, the precast specialty engineer, and erector. During construction, each of these parties is responsible to communicate with the other parties. And that's usually through one of these two groups. It's either a construction manager or it's the general contractor. There is a necessity to have those lines of communications. And you can, in the CM or GC can do this either through written documents, or he can specify them during a pre-construction conference. So in the design of precast concrete, sometimes it is more often than not, it is designed and reviewed after the precast work is under construction. It's not often that a precaster has to provide structural calculations and drawings that show how the precast fits on the structure prior to construction. It's usually done after the precast work is under construction. However, if the architectural precast erection drawings are needed for the permit set, and that might be necessary depending upon how the project is submitted to the local building officials, that might require a seal of the precast specialty engineer prior to everything being under contract. So there may be some opportunities, or there may be some requirements for the architectural precast erection drawings being needed well before they are ever executed. Now, I said something about the standard of care. This is the definition that we got out of the ACI dictionary, and it's the one that we used. I'm sure that if you go to a lawyer, you'll get another one. I can recommend a colleague of mine at WJE who can give you an hour and 15 minutes on the standard of care. But fundamentally, this is the definition that we use. It's the level of skill and competence ordinarily and contemporaneously demonstrated by professionals of the same discipline, practicing in the same locale and faced with the same or similar facts and circumstances. The long and short of that is, I, as a structural engineer, oftentimes are asked to review other structural documents and calculations and plans. The standard of care is, did the person do it with all of the correct load path? Did he do it with the correct load factors and things like that? I may not have selected the exact construction that the other individual is suggesting, but if they can demonstrate to me that they can do a safe design, that to me represents a standard of care. Now, our first person who has responsibility is the owner, and the owner's project requirements and responsibilities include establishing overall goals. He has to also express an opinion on the type of building, whether it's concrete, whether it's steel, whether it might be a precast concrete building, or even something like a wood construction. He has to specify the intended use. And by that I mean, what is the building supposed to be used for? Is it an office? Is it a residential? Is it a warehouse? Is it supposed to be multifunctional? Is it supposed to be able to be converted from one use to another? That necessarily comes from the owner. There's also a project delivery method, and that is to some extent up to the owner. Certainly, there is the design, bid, build option, which is very typical of most construction. There's also a design build option. And we can also do this with a construction management at risk or a construction management multi-prime approach. So the design delivery approach is something that needs to be defined early by the owner and working with his particular team. More often that is the architect. And if the owner already knows and has a desired builder, work with the builder. He certainly needs to keep track of budget and schedule. If the schedule and the budget are going awry, that it needs to be reined in by somebody, and that should be the owner. So 2 slides back, we talked about who's on this team, and the question is for architectural precast, who is the owner's representative? And more often than not, the owner's representative ends up being the architect of record. So architect is got a lot of responsibilities. His responsibilities include those that are associated with the contract documents. Those contract documents develop the project concept. If the architect's drawings don't develop that concept, the rest of the team begins wandering around, wondering what they need to do. That those documents need to establish overall structural geometry. It has to select the materials and appearance and its function. It should specify tolerances and quality characteristics. It should also provide some details, not all of the minute details, but details of what the joints might look like between elements. Those architect documents should specify some kind of performance or quality characteristics, and it should not neglect testing and inspection requirements. The architect or the structural engineer of record may be specifying what portion of the design is the responsibility of the precaster. Now, the precaster, the structural engineer of record usually designs the building frame, but is not necessarily involved with the detailing design of the architectural precast. That is called a designated design, and the precaster is responsible for that designated design. Those contract drawings must definitely define what the scope of the architectural precast design is before any kind of precast design is undertaken. Architectural drawings should show where the reveals are, primarily where the reveals are. However, it really should be the precaster's decision on panel size, because the precaster understands and knows how to handle, how to erect, and how to make the connections to the building. The structural drawings should identify the general performance and also the design loads, and make sure that the structural drawings have the design loads for the precast panels that are being attached to them. They will usually define strength, deflections, and temperature considerations, and also either in the structural specifications or in the architectural specifications, the project manual, tolerances and clearances should be reviewed and identified. So for a drawing summary, the architect should have both building location and site access shown on one of the cover sheets. It should show elevations, wall sections, dimensions. It should show basic details of joining and interfacing with windows, roofing, panel to panel sealing for air and moisture. And also locate the reveals. In some cases, those reveals are real, like along this edge here. In some cases, they're false, like along these two lines in this architectural precast panel made to look like terracotta. The additional thing that must be shown on the drawings from the architect are what the required materials are and the color and finish. That's the architect's job, is to select those out of some kind of a palette. If it's an insulated panel construction or insulated system, it also needs to be able to define what kind of insulation capability that panel has to have. And then there are other details like the fire endurance requirement that should be either in the general notes or in some kind of specification. Does this need to be a 5-hour fire rating or just the 1-hour fire rating, so that that is part of the design of the precast, architectural precast element. Dimensional tolerances are, of course, a primary concern, and the recommendation from this committee from ACI is don't screw around with the industry recommendations. The industry recommendations, from my knowledge, are identified in PCI Manual 117. It's called the Manual for Quality Control for Plants and Production of Architectural Precast Products. There's also another document, the Tolerance Manual for Precast and Pre-Stressed Concrete Construction, MNL 135. MNL 135 is more attuned to structural precast as opposed to the 117 manual, which is architectural precast. And again, don't let anybody fool around with these tolerances. The industry knows what they can do, and these documents are available. I don't believe I saw any tolerance recommendations on the APA website, nor did I find one on the NPCA website. So my point of reference here is that PCI has a very good manual on tolerances. When the architectural precast is finished, the architect and the structural engineer should be reviewing these shop drawings for conformance, and that's a conformance to the design criteria. Do they conform to what was on the architect's and the structural engineers' drawings? Did they meet the load requirements? Are the connection points reasonable and appropriate for loading the structure with this externally applied load? In addition to that, the precaster is more often than not obligated to submit design calculations for the architectural precast for review by the structural engineer, and those calculations need to be approved really before the precaster begins his fabrication process. The procedures that is found to be most successful is that there is a need to have an architectural mock-up sample. And approval typically requires an approval of a mock-up. The mock-up should really include things like the returns and the special features. Sometimes a full-scale mock-up is necessary, but without doubt, some color range and texture mock-ups are important for the precaster to make. And it usually produces at least 3 range samples. In other words, these are ranges of the color as well as texture, and these samples are anywhere from 15 to 20 square feet, so it's like a 4x4 piece, so that they show both color and surface texture. And then the architect establishes what range of acceptability he's content with. And then the precaster has to meet those acceptable ranges. The architect oftentimes has some detailed testing requirements, and this is particularly important when you need to evaluate the panel water tightness as well as the joint water tightness. Panel water tightness for concrete is pretty easy to do unless you have a whole bunch of cracks, but the joint water tightness is something that really needs to be tested, and a full-size mock-up is probably the best way to assure that we get water tightness. You can either do that in the laboratory, in a laboratory environment, or you can have an in-place panel on the building, and we use that for a mock-up to test the joints between panels as well as for the junctions of windows and doors and things like that make penetrations with the architectural precast. In terms of panel inspections, it's suggested that the structural engineer or architect create a checklist to verify conformance with those key items in the contract documents. And then it doesn't make any difference if you do the checklist unless you meet with all the parties involved to address the inspection concerns. And once you have those inspection concerns, the precaster must do some repairs as required to meet the architect's aesthetic requirements. That means that not only the panel, but the repair needs to fit in the color range and texture for the range samples. And also there is another PCI document to evaluate visual acceptability. That's PCI Manual 122, Architectural Precast Concrete. And the basic rule of thumb there is if you look at it from 20 feet and find something, it's probably a requirement for some kind of repair. The structural engineer of record is the person who needs to consider the weight of the precast on the structure he is designing. He certainly needs to be very cognizant of the fact that most of the stuff hangs off the side of a building, so it's eccentric to columns and eccentric to slabs. So there's oftentimes a torsion involved. And the structural engineer needs also be aware of what happens if I put all the precast on one side of the building and nothing is on the other side of the building. Does that rack the frame? Does that create a misalignment of the frame? What are the unbalanced loads that are acceptable to the structural engineer's frame? The structural drawings, the structural engineer should show where the panel gravity and lateral loads are to be connected. He doesn't have to necessarily put the precise locations, but he needs to know, the precaster needs to know about where the connections are to be added. And if the connections are not on the slab for facade kind of panel, they have to go to the column someplace or another. And that's a decision that the structural engineer makes. And he also needs to be concerned with the type of framework. Is it a steel frame structure or is it a concrete frame structure? Because they have different requirements for making attachments. Steel frame structures are probably a little easier to make attachments to, whereas in concrete structures, you need to have some kind of embed or connection piece embedded in the concrete such that a connection can be made, and that means the contractor has to be involved. The structural engineer also has to have a good knowledge of governing codes and deflections and temperature. He needs to delineate the lateral bracing for beams, and he should be making a statement about what the precast components are for design, to be designed by the precaster, and who is responsible for the interfaces, the secondary bracing. Is it the precaster's responsibility, or is it the structural engineer of record's responsibility? There's also some details of required clearances and load transfer points for the structural engineer on his checklist. General contractor, his responsibilities are really not too extensive. It's either a GC or a GM, a CM. Those GC or CM responsibilities include construction means and methods, the sequence of construction, site access, construction procedures, schedules, and by last but no least is site safety. The site safety is the responsibility of the construction manager or the general contractor. In a reinforced concrete structure, the GC or CM is responsible for placing the embed items. He should also be providing some kind of as-built survey for the embed items to verify that they're consistent with where the precaster wants to make his connections. For a steel structure, that's usually assigned to the steel fabricator, and then the precaster needs to work closely with the fabricator, the steel fabricator, contractor, or the precast erector in order to make sure that the connections are in the right place. If any of those loads or those temporary loads exceed design loads, they need to be brought to the attention of the structural engineer, and the structural engineer needs to make a suggestion as to their acceptability. Now we'll finally get around to what the precaster's responsibility are, and he's usually a subcontractor to the GC or CM, and the precaster is responsible for preparation of those component elements and design and fabrication of those components. He prepares precast shop drawings, designs and details the connections between the precast, architectural precast component and the structure. Usually he provides the connection hardware, and he then proceeds to fabricate the component in accordance with what the acceptability color and texture is. He's also responsible for quality assurance for the concrete, for the texture and for the color. And then he has to work closely with the erector to make sure that the products are delivered in a timely fashion. The first step that the precaster needs to do is to determine panelization. I don't think it's appropriate for an architect to make those final decisions. I recently had an experience where the architect was trying to figure out, do I want to make upside down E's, or do I want to make W's? Do I want to make punched openings? And where do I want to put all the joints? And my comment was, why don't you let the precaster figure this out, because he knows where it's most efficient and easiest to make the connections. And he also knows something about where the structural engineer of record has all of he can put all of his connection hardware. So the first step is to determine panelization, and you have to balance the cost of panelization to construction. As oftentimes you can improve efficiency with a certain panel size, and certainly facilitate the erection of the precast on the frame. Drawings for the precaster are to provide detailed calculations. Those detailed calculations are reviewed by the engineer of record. The precaster's drawings should show the shape and the erection drawings, and those drawings should be sealed by a professional in the state of where the project is sited. Precast drawings should show design criteria, the materials, the interface details that are not on any of the structural or the architectural drawings, and any magnitude and location of design loads applied to the structure, so that the structural engineer of record can have a basis for evaluating the effects of the precast on the structural framework. Design for the precast, there really are 3 design responsibility options that are listed in the 533.1R document. They are summarized in extensive detail in table 3.5.3. And basically, this is an overview of that. The first option is where you have an architect has not a string background, but a strong background. My error, apologies. If the architect have a very strong background in architectural precast, he may want to do all of the design documents. Option 2 is the more common approach, and that is where the owner and the architect assign and designate the responsibilities of the precast design to the precaster. This more often than not accelerates permitting. And there is a third option called a hybrid design, and that's where the design responsibility is split between the architect and the precaster. And in the next 3 slides, I have those design responsibilities outlined as they are in the 533.1 guide. On the left-hand column is what the owner is to supply, and on the right-hand side is the responsibility of the precaster. I'm going to go through the precaster responsibility here for option 1, where the architect has a pretty strong background in precast concrete. The precaster creates the shop drawings and for erection and production. He suggests modifications to improve economics, to improve structural soundness, and improve performance. For option 2, and I said that's the more typical approach, the precaster's responsibilities are submit the erection and shape drawing for approval, assume the responsibility for the component structural design. That means that the precaster takes the responsibility for the design of the precast component, but no responsibility for the component's effect on the building. That's the structural engineer of record's responsibility. And then he has to stamp the drawings or hire a specialty engineer. And the third is where it's kind of a hybrid, where the precaster's responsibility are start at the very preliminary design stage. He helps develop the final details and specifications for the component. Then he provides the engineering design for the components and submits the design information for approval by the architect and owner. The specialty engineer, that is the person who is hired by the precaster, is a licensed structural engineer. He specializes in designing precast and pre-stressed concrete. He's actually responsible for all the structural design of the components, the connections, the lifting, handling, and structural aspects of erection. How do you pick and how you roll and how you manipulate a precast panel once it gets to the site is his responsibility. He is not under contract for anything that the engineer of record, the structural engineer of record, is responsible for, unless the specialty engineer is actually assigned that responsibility. And he certainly must coordinate with the engineer of record when the specialty engineer takes exceptions to specific criteria or reference standards. And I can give you a quick story about things that are happening within ACI. There are many exceptions to ACI 318 that the precast industry, precast structural design industry takes. The precast industry is now writing its own design standard. It has a title ACI 319 as opposed to ACI 318. ACI 318 has sections in it that deal with precast concrete. Eventually those sections are going to come out and there'll be a precast code, ACI 319. And there's also a move to create a design code for post-tension concrete construction. So things are moving toward a code for designing precast concrete. And there are many exceptions that the precasters take with respect to things that are in the ACI code. And hence this is a good step. The erector, of course, he's usually a part of the precaster's contract. Precasters oftentimes perform the erection with their own crews, their own erection crews, although there are precast erection contractors who specialize in this, who are available and are not necessarily employed by the precaster. The erector should be laying out the structure prior to any kind of erection of precast. He should be locating the joints and all the elevations of components to find out if there are any conflicts. And if he identifies problems or misalignments or out of tolerance issues, it needs to be addressed ASAP. There is an installation quality assurance manual for precast erection from PCI. It's manual 127, erector's manual standards and guidelines for the erection of precast concrete products. And as APA has, there is a certification program. So PCI actually has a certification program for precast erectors. Hardware, oftentimes we scratch our head and figure out who's responsible for this. And I can't give you a straight answer. It depends. It depends upon whether it's a cast-in-place concrete structure, a precast structure, or a structural steel structure. There's no standard answer to this question of who has the responsibility of providing all the hardware. At the bidding and contract documents should really clearly show who furnishes and places all this field hardware. Oftentimes a precaster has to install other accessories into and hardware into the architectural precast, maybe not on the outside of the panel, but on the inside. So if there are electrical boxes, conduit, window inserts, or fastenings for other trades. Or if it's a parapet panel up at the roof, you provide a riglet for terminating a roofing membrane. Those items and those pieces have to be provided to the precaster prior to fabrication. In general, the precaster provides the miscellaneous loose steel, either pre-welded or pre-bolted to the panel, so that the erector can do the erection and not let the panel hang on the side of a building for a day before things are attached. Procurement and bidding process. This is the last part of ACI 533.1R, and it provides a timeline. So what it does is it provides a checklist and a system of things that should be done in step one. And the first step is verification of the architect's concepts and systems. Second step is at the pre-bid conference, make sure you understand all the architect's concepts and wishes, and then fully understand your responsibilities. And then at the post-bid scope review, repeat those responsibilities and discuss timelines and schedules and things like that. And at any pre-construction step 4, you need to provide a path of communication between you and the other parties in the I'm sorry, excuse me, other parties in this project. That is the end of my discussion. I think I have a few extra minutes. Again, this document is available. It's was published in May of this year. I think this actual publication date was May 4th. It's available through ACI in their bookstore. If you're an ACI member, it's $34, and if you're a non-member, it's $54. But it's an 11-page document. It's a revision of an initial document that was created in 2002, and it's an important document because it really does help define responsibilities, and responsibilities prior to 2000 were not very clearly defined and caused a lot of confusion. So with that, I will entertain any questions and or turn it back to you. I think you have another thing on your program that's going to start very shortly.
Don, can you hear me?
Yes.
Great. I do have a handful of questions for you. And the first one that came through is, as precasters, we often find ourselves where project owners and general contractors are in a huge hurry. They want the product yesterday, but we can't even get complete drawings from the architect. Any thoughts on how to deal with those situations?
Send your salespeople to the architects once you hear the project is going forward. Keep your fingers on the pulse of the construction industry and try to get in there as early as possible. I don't have a solution for that, and I don't know if any construction manager or general contractor has a solution for it. Things these days are intended to be built fast. The caution is, don't build them too fast, because the faster you build, the more errors and poor construction you create, and that's not what you want for an architectural precast panel.
Okay, thank you. The next question is, are there any limitations to what can be specified as a delegated design?
Oh, yes. The architect or the structural engineer can specify exactly what the specialty engineer or the precaster has to design. If the structural engineer wants the specialty engineer to make sure that the structural frame is acceptable, he can delegate that responsibility to the specialty structural engineer. In terms of limits, it's a cooperation between architect, engineer of record, and the precaster's specialty structural engineer as to what the design responsibilities are. The primary responsibility for the specialty structural engineer is to, once the precaster has done his panelization and decided what the panel wants to look like in terms of reveals and sizes, the structural engineer designs it for the structural loads that it has to carry, and produces the shop drawings, the elevation drawings for erection, and then add a set of design calculations for review. But it's really, it's a cooperation between the structural engineer of record and the specialty engineer as to what the structural engineer of record might want the specialty engineer to do.
Okay, great. Very informative. Our next question we have, when speaking of shape drawings, are you meaning individual production tickets, or are you speaking of just showing profiles?
Well, I think the architect has a responsibility of kind of defining what shape he wants to see, but shape drawings are those drawings that actually show where the reveals, where all the whether it's a flat panel, whether it's a C-shaped panel or something like a channel shaped panel. Those are the shape drawings that the especially structural engineer produces and gives back to the precaster for submittal or approval. So to me, shape drawings are the final product. What is the shape of panel WPX, wall panel or spandrel panel Y? What does it look like? What's the finish is supposed to look like? And the structural engineer of the specialty engineer, excuse me, again is oftentimes producing shop tickets too.
All right, and keeping on the topic of drawings, our last question is, if drawings don't clearly show which party provides hardware, how best to assign who does what?
How best to define who does what?
To assign, yes.
To assign who does what. I think the best thing is the precaster takes control of that process. The precaster, through his specialty structural engineer, need and understand the best way for a panel to be hung on the building, and how to work with the erector, and what connection types are most efficient for the type of panel that's going on the building. The structural engineer of record oftentimes has never done a precast project, so they're ignorant of all of this information. So the precaster, I believe, should be taking the prime responsibility of providing and locating the connection points for lateral support, for gravity support, and whether it's on the slab or the column, or whether panel-to-panel connection, that really should be the under the precaster's control.
Okay, thanks.
Okay, thank you, Don, for the time today and for explaining the new ACI guide to our members.
You're welcome.
We've all learned a lot, and thank you for your work on behalf of the precast industry.
My pleasure.